Hello friends, welcome back to my IoT tutorial series, and today we are going to learn about MQTT protocol. So before I begin with the actual features of MQTT protocol and all about MQTT protocol, I would like to thank IoT Eclipse community. Because of them, a lot of open source libraries, packages are available through which you can implement the actual implementation of MQTT protocol, whether it's C programming, Python, Node.js, Java, C++, and HiveMQ as an enterprise MQTT broker. They also have provided very good documentation on their website, and PAHO is open source project that is initiated by IoT Eclipse. So IoT Eclipse has major contributions, so I am very thankful to them. So let us begin this what actually MQTT protocol is and what actually publish subscribe communication model. And then the first picture that you are seeing, that is the actually logo of Mqtt broker, and Mqtt is an open source broker. So most of the thing that I will be using for the pragmatic solutions, those things are going to be open source, right? So let me first tell you the agenda of the today's session. So agenda of today's session is what is the need of protocols, little bit history about MQTT, how MQTT came into the existence, what was the need of MQTT, and then introduction about MQTT protocol, publish subscribe model, packet structure and header, wildcards, last will and testament, retain message concept, clean session and persistent session, keep alive time interval, what is the job of these keep alive interval, and then what are the security options available in MQTT protocol. So first of all, what actually protocol is? Protocol is nothing but it is set of rules and guidelines for communicating data, right? But there is very obvious thing that actually will come in your mind, that there are a lot of protocols like FTP, file transfer protocol, RTP, HTTP are present from traditional. What is the need of a specific IoT protocol? And then there will be one more natural question that hits very sharply in the head, is that why are there any protocol outside of HTTP to transport data across WAN? So the whole community, before moving into the MQTT, that thinks about, I know client server architecture, I am very much familiar with HTTP protocol. Whenever we have to transfer data to the global network, why should I learn uh, MQTT protocol, right? So first of all, of course, HTTP has provided significant services and abilities for the internet over 20 years. Yet was designed and architected for general purpose computing in client server model. This means that whenever I talk about HTTP, this HTTP protocol are not designed for some specific applications. It was for like general purpose computing. You can play around client server architecture, and you can send a lot of requests. You can play around a lot of kind of data like PPT, PDF, JPEG, audio, MP3, MP4 files, and these things you already will be familiar with if you are familiar with the web browsers like Google Chrome, Mozilla Firefox. They are client, and from servers you are dealing with to getting those data by putting those URLs, right? So let's move ahead and see what is the need of protocols, right? So the major important aspect about protocols is that whenever you have to transfer data, you need these protocols, right? So if I talk about in IoT context, so I was discussing in my one lecture where I have talked about fundamentals of IoT. I will share the link where you can go and understand the IoT reference architectures and all. So first important aspect is that you have to transfer data from device to device. It could be like two end devices through which you want to make communication. It means generally device to device communication. Then you again need some protocols or some means to exchange those informations. And then sometimes you require information to be transmitted between devices and gateways in IoT, right? And then you also require directly two-way communication between device and cloud platforms, or you can say servers, or you can say IoT platforms. And then from gateways, or you can say middleware to servers, right? So these are certain combinations that exist in IoT ecosystem where you need protocols for transmitting the data. And then again, important aspect that whatever data you are exchanging, that must be represented in readable format and it must be encrypted so that there should not be eavesdropping of the data and no one can enter into your data, no one can tamper your data, no one can breach your data, no one can breach your network, right? So, and then most important aspect in IoT ecosystem is like whenever we talk about resources, so we need to take care of two important things. One is computational capacity, and second important factor is power, right? So computational capacity, when I talk about it, means we are more concerned about memory, we are more concerned about processing capability of that particular uh, device that you are using in, and then bandwidth, right? And power means generally in IoT ecosystem your devices are going to be deployed in the remote locations, your major work is going to be from remote areas. Then power consumption is also one of the important aspect that need to be kept into the consideration while discussing about any protocol. So let us understand the historical perspective of your MQTT protocol. So now MQTT is an open source protocol, but initially it was not open source, right? So basically the tech giant IBM, they actually given the name Web Sphere Message Queue technology, right? Was first conceived in 1993 to address problems in independent and non-concurrent distributed system to securely communicate, right? So a derivative of the Web Sphere Message Queue was authored by N.D. Stanford Clark and Erlen Nipper at IBM in 1919 to address the constraint of connecting remote oil and gas pipelines over a satellite communication. So this was the major thing. That's how your MQTT protocol implementation started. That they started thinking that how I can connect remote oil and gas pipelines over a satellite communication. So they started coming up with this concept of something called Web Sphere Message Queue, right? So MQTT was an internal and proprietary protocol for IBM for many years until being released in version 3.1 in 2010 as a royalty-free product. So when I say royalty-free product, it means it was open source. Anyone can download the source code and can tweak those codes according to your requirements. And in 2013, MQTT was standardized and accepted into OASIS consortium. So this is one of the major throwback you can say in a MQTT protocol, that it got standardization. So OASIS released it publicly in 2014 as version 3.1.1. That is the most stable version. So MQTT is also an ISO standard, ISO IEC PRF 20922, right? So you can now at least trust on this protocol that we have a very set consortium OASIS. They basically maintain all the documentation related to your MQTT, and it is now also ISO standardized, right? So latest version for MQTT was 5.0. So it was in review, but now it's actually available. A lot of new features are available. So in some session, I will discuss about MQTT 3.1.1 and what actually new is there in MQTT 5.0. So if you will go on mqtt.org, so they have actually put up a very concise summary of MQTT protocol. They say like MQTT stands for MQ Telemetry Transport, and it is a publish, subscribe, extremely simple and lightweight messaging protocol. And this thing you will be getting more clear in coming slides, that what actually the meaning of simple and lightweight messaging protocol. Designed for constrained devices and low bandwidth. It means specifically to IoT and M2M applications. High latency or unreliable networks. Of course, in IoT, most of the time you can accept latency, and you can also talk about unreliable networks, because generally the data that is coming from the devices, it means I'm talking about sensor data, hardly change frequently, right? So the design principle are to minimize network bandwidth and device resource requirements, while also attempting to ensure reliability and some degree of assurance of delivery. So these concepts we will talk more in detail, like how you can ensure reliability, what are the some degree of assurance of delivery is available in this protocol. So these principle, like some set of reliability is there. It was basically designed for low power devices, constrained network, right? So this become an ideal for the emerging M2M and IoT world of connected devices and mobile application where bandwidth and battery power are at a premium. So this become, one of the major choices for M2M and IoT based applications. So this you can go on, like certain links I have put up there. So you can go and you can read it out about OASIS 3.11 documentation easily. So those links I will share where you can go on official pages and you can find it out. The OASIS 3.1.1 implementation detail, you can easily read it out, and then uh, you can get a lot of things more in detail. So let's start with the actually what MQTT is, right? So MQTT is basically publish subscribe model, right? So this is something new from your request response model in client server architecture, and mapping done through topic name. So publish and subscribe and topic, these are three important factors that you must understand in MQTT protocol. So we will be discussing these things like a publisher, subscriber, broker, topics more in detail. So topic names can be hierarchical, like your file folder structure that you see in Unix based systems. Like say you have created a file, say IoT data. Inside IoT data, you can have like temperature sensor. Inside temperature sensor, you can have like Pune region, and then in Pune region, you can have like exact data. So it's like a folder inside folder inside folder. So similar to that is like hierarchical topic names could be there. For example, you have deployed a sensor in Pune location, so it could be like state slash Maharashtra slash region slash Pune slash temperature, and then you can have some value like 27 degrees centigrade on that topic. So this way you can basically name topics. So by default, it works on TCP transport layer, and TLS and SSL for security is possible. It means secure socket layer and transport layer security. SSL is deprecated due to some security reasons. So majorly now the secure communication is implemented over TLS. By default, your broker, right, that connects your both the clients, publisher and subscriber is runs at port number 1883, and in secure mode, it runs at port number 8883. Unlike a traditional client server model, the clients are not aware of any physical identifier such as IP address and port. So this is very important thing. Let me give you more in detail. So suppose there are two clients, one is publisher and one is subscriber. So who is publisher? Publisher is the one who is generally publishing the data. Subscriber is the one who is subscribing the data, right? So that I will talk in more in detail. But just giving you an idea that these two entities is going to communicate through broker. So they don't require that who is publisher and who is subscriber. It means publisher doesn't require to know about subscriber directly, and subscriber doesn't need to know about publisher directly, right? So that's what is the meaning of this particular last statement. So MQTT basically has three main components: publisher, subscriber, and broker, right? So publisher publishes the data over topic, and subscriber has to subscribe to that topic in order to receive the data published over to that topic. So these things, once we will be doing practicals, we will get more clear exposure that how these things are going to work. So publisher, a client transmitting a message is called a publisher. For example, you can have like a small IoT device, teeny device that is very constrained in nature, that one sensor that is connected with that particular device, say temperature sensor, and it is actually giving you the real-time temperature value, right? So that could be a publisher client. So generally IoT devices connected with the sensors are publisher devices, or you can say publisher client. And subscriber is the one who is going to receive these data that is coming from devices. So generally it could be any cloud platform, it could be any particular gateway where you can run your subscriber to receive these data. So it could be in any web format, or you can use Linux based utilities to receive those data that we will see in practically, or to design prototype in very less time. You can use Node-RED based flow-based programming tools also for implementing these things that we will see. And broker is basically going to connect these two clients and also going to filter the data, right? Filter the data means how your data is going to be channelized, right? So next important thing is about packet structure, right? So like what is the header size, maximum payload, and all these things is basically come inside a packet structure. How data flows from client to broker, right? And broker to client. What are the packeted exchange between different quality of services and all that is actually mentioned inside your packet structure. So the very important aspect about this MQTT protocol is that it comes with minimum 2 bytes for essential header for payload up to 127 bytes. So you will not find any protocol that has this offering of having 2 bytes of header, and it can have maximum 127 bytes of data with that 2 bytes of header. You can imagine that like 127 bytes of data you are sending with 129 bytes actually while moving to the cloud platform, right? So it is going to, save lot of header size. And in a backdoor, if you try to understand, it means you are going to save lot of bandwidth. Processing is going to be less. That's why MQTT is one of the first choices for any IoT developers. And maximum size of header is 5 bytes. So you can start sending the data with 2 bytes, and maximum it can reach up to the 5 byte depending on the payload size, right? So if I talk about MQTT headers, your topic names, client ID, username, and password are encoded as UTF-8 string. Other than that, most of the things are binary encoding, right? The payload excluding MQTT protocol information like client ID is binary data, and the content and format is application specific, right? Like it could be your JSON format, it could be your text format, whatever you are actually going to be. The MQTT packet or message format consists of 2 byte fixed header that I was discussing, and always present, it will always be there, plus variable header that can reach up to maximum 5 bytes. It means 2 plus 3, 5 bytes. And sometimes payload is not available. Reason is that many times you are sending someone particular packet that is just going for like, for example, connect packet, right? These things you will not get right away, but once we will get into the practical implementation, you will get it very clearly that once you are sending connect packet to the broker, it means you are trying to connect to the broker, and broker is sending con ACK, connect acknowledgement, that your communication is established between publisher and broker, or might be between subscriber and broker. So in that case, there is no particular payload involved into it. So possible packet formats could be like fixed header, control field plus length, example con ACK. That particular packet is actually sent whenever connect acknowledgement is there, right? It means you connected with the broker, and broker is sending back a packet that you are now successfully connected to the broker. So that packet is called con ACK. So fixed header, in that case, control field plus length plus variable header. For example, pub ACK. With publish acknowledgement, you could have variable header. It means reason is that payload side may payload is there in publish acknowledgement, and in that case, your variable header size may increase, right? And in fixed header side, you can have control field plus length plus variable header plus payload, right? So example, connect. Okay. So depends, like in these scenarios you will get more clarity while we will be doing more practicals. So this is the packet structure. You can talk about like packet length can be 1 to 4 bytes. That's why it could be like maximum 5 bytes, and 1 byte of control header is always fixed. Variable length header 0 to y bytes, it means it depends, and payload 0 to x bytes, depend, right? What kind of information we are going to exchange, or we are going to only connect, or we are going to also exchange some informations, right? So if you talk about control header, there is a control field and packet length. Okay, so packet length field is 1 byte, which is for message with a total length less than 127 byte. So let us see what actually the control field means, that is of 1 byte. Here you can see there are different control packet types: connect, con, ACK, publish, right? So connect is basically sent between client and server to initiate the communication, right? That you are trying to connect with the broker so that you can, start communicating and you can send some data from the device to the gateway, and then on gateway your broker is running, right? And then you have con ACK. So once connection is successful, you get con ACK packet, and publish is basically the actual packet where actually your sensor data and all is there, right? So publish packet is the packet that is basically available in quality of service 0, 1 and 2, right? So this is the first packet that is sent as a data, right? So these things are given more in detail. If you wish to uh, find it out, you can refer OASIS documentation like connect, con ACK, publish, pub ACK, pub REC, pub REL, right? So like publish and pub ACK, publish acknowledgement, right? So whenever you deal about quality of service one, you get the acknowledgement also, right? So that for that you have pub ACK packet. So this way actually your if I sum up, this way your MQTT protocol works. So there is a MQTT broker that is installed on your gateways or on cloud platforms where you are actually going to receive the data. So depending on your requirement, you can install your MQTT broker, and then you have some sensor that are attached with the devices where your publisher client is running, and it will send the data to the broker, and then through broker subscriber can subscribe to the topics on which publisher is publishing the data. For example, topic name is temperature. So if subscriber will subscribe to the temperature topic, it will receive all the data that is coming from the devices that are publishing the data to the temperature topic, right? So in this context, there are certain concepts related to a topic called wildcards, right? So what does wildcard means? So wildcard was introduced for like whenever you are dealing with multi-level hierarchy, right? So in multi-level hierarchy, if I talk about, there could be a case where, you know, for organizing the data, you can have like installed some sensor that is inside your home ground floor, and in your ground floor there is a living room, and then in living room you have installed your temperature sensor. So you organize the topic in this way: my home, ground floor, living room and temperature, right? So sometime it may happen that you do not want to remember exact hierarchy, right? And you want to bypass certain hierarchy of that particular topic. So generally wildcards are used at the subscriber end, not the publisher end. Publisher end, you exactly write the hierarchy of the topics. For example, my home, ground floor, living room and temperature, right? So if someone is publishing the data on my home, ground floor, living room and temperature, so at the subscriber side, if you will subscribe to my home, ground floor, kitchen and temperature, you will receive the data because topic hierarchy is exactly matched. Having said that, if you are going to use like this: my home, ground floor, kitchen and brightness, you will not receive the data. Now try to understand, on the top of that I have written my home, ground floor plus temperature. It means a third level hierarchy I have used plus. Plus is a wildcard, single level wildcard, right? So it means my home to my home is mapping correct, ground floor to ground floor is mapping correct, and then the topic is basically living room, right? So in living room, if you are going to use anything in place of living room, you can use like kitchen, you can use like uh, your hall, you can use like your bedroom, anything could be there because you have used plus. So in place of plus you can write anything. So in the third one, my home, ground floor, kitchen, that's perfectly fine because hierarchy is maintained if you will look at the my home, ground floor, living room, right? So third one in plus, that's perfectly fine. But fourth one is temperature. There we don't have any, wild card use. But here you see brightness. So temperature and brightness is not matching. It means at the fourth hierarchy, you are not going to receive the data because topic name should be matched properly. Now coming to the fourth one, my home slash first floor, but go into the main my home, ground floor, right? So here, if you will write first floor, you will not going to receive the data, right? My home, ground floor slash kitchen, that's perfectly fine because at third place it is plus. So it is okay. You either write kitchen, you either write in place of living room, you can write anything, right? But the fourth side, in place of temperature, you are writing free. So there is no wildcard used at that place. So you will also not receive the data. So this way single label wildcard works. So while we will be giving these demos, specific sessions, I am going to prepare for this to give you the more practical exposure. So you will get more clarity of all these things. Then you have something called multi-label wildcard, and multi-label wildcard is important whenever you want to, bypass multiple labels. For example, we have my home, ground floor, living room, and temperature, right? This is my publisher topic. So if anyone interested, if it subscribe to my home slash ground floor slash hash, it will receive the data coming from my home, ground floor, kitchen, temperature easily, because it doesn't matter after the two label whatever is written, whether it's written kitchen and temperature, I don't care about this, because has after that anything, two initial two hierarchy need to be maintained. My home, ground floor, that's okay. In place of that, it's kitchen or brightness, I don't care. I will receive the data, because has means anything after my home and ground floor. So anyone that is publishing on these two hierarchies, after that he's using 8 hierarchy, 9 hierarchy at publisher side, I don't care if I will add hash. But if I am writing my home slash first floor, I am not going to receive the data, because my home and ground floor and second hierarchy, it is not matching, right? So this way your multi-label wildcard can be used where you are not aware about multiple labels, right? So you can skip 2-3 labels at a time just by applying hash. So there is something, a special topic called sys topic that is available in your MQTT, and this is basically used for broker statics, right? So it start with dollar. So like how many clients are connected to that broker, you can just use dollar sys broker clients connected. So you will get the stats about how many clients are connected with that broker. So sys topics are special topics that are basically used to get the broker statics. Then there is a question that people ask generally, what is the maximum allowable packet size, right? So maximum allowable packet size is 256 MB, which allows for an extremely large payload, but again it dependent on the implementation, right? Cloud and broker dependent. So generally, like if I talk about IBM Watson, so the latest update that I checked, it was with 128 KB, might be it may increase. And then Google, if I talk about GCP, it's supposed to 256 KB. So maximum, packet size that could be between 120 KB to 256 KB if you are using IBM Watson and Google. So depending on totally this implementation is dependent on what kind of brokers and cloud platforms you are going to use. So if I talk about quality of service, so this is one of the very important features of MQTT, where you can decide that you want more reliability or less reliability, more latency or less latency, right? You want acknowledgement or not. So there are basically three kind of quality of service. It is quality of service 0, 1, and 2. So in quality of service 0, we said fire and forget. You send the data, but you forget that your broker has received the data or not, right? In quality of service 1, it means at least once. Your data will be published at least once to the broker. Until and unless you will not get the acknowledgement from the broker, your data is going to be retained by the client, right? But there could be duplication also. That is the meaning of at least once. So it could be like twice and thrice if there is a delay in acknowledgement. And in quality of service 2, exactly once. Exactly once means that at least once was means you can get duplication also in quality of service 1. But exactly once means there is not going to be any duplication. So your data is going to be received only once, right? So there are like 4 flows that are available into it. So those things I'm going to discuss in next slides, how it works. So generally in quality of service 0, there is only published packet that is sent by the MQTT client to the broker. Published packet basically carries the data, right? Sensor data, and it doesn't care about the acknowledgement. Your data is sent and it doesn't matter that data is received by the broker or not. So, but this particular quality of service 0, if you are using an MQTT protocol, your reliability is less, but speed is faster. Memory is going to be used very less for processing, and of course, for constrained environment, it is good. But reliability is going to be one particular issue here, because there is no acknowledgement. quality of service 1. So there is an acknowledgement, but there is a case of duplication. So you will send publish and then you are going to receive pub ACK. It means broker will tell you that I have received your packet. But if there is a delay, you might receive the duplicate message also. But in quality of service 2, you have like publish and then pub REC. You send the data from the client to the broker and then broker will tell you that I have received your data. So whatever data you have retained at the client side, now you are going to release that particular data or packet by sending pub REL. Then broker will understand, okay, he is releasing the data and it will say, okay, now pubcom packet I am sending to the client. It means that communication is completed between client and broker. So there is no duplication in quality of service too. So if I brief quality of service, when we are moving from lower quality of service to higher quality of service, you will observe that latency is increasing, but at the same time your reliability is also increasing, right? That there is no duplication in quality of service too. There is a feature called lost will and testament in MQTT, and this is one of the important features when there is a problem in the publisher where actually your sensor data is coming, right? It means there is some network problem. It may happen that automatically device got stopped due to some battery problem. It means that is called ungraceful disconnect. Willingly, this has not been disconnected from the broker. So in that case, you can use last will and testament feature. So whenever your device will go offline due to some ungraceful disconnect, so in that case you are going to receive a debug message, whatever you will going to put in uh, bill payload. That particular message you will receive. For example, device stop sending the data, device 1 that is deployed in Jodhpur has stopped sending the data, right? Device 2 that is deployed in Pune has stopped sending the data. It means this is very important feature in MQTT whenever you have to debug that from which source there are thousands of devices, but 5 devices are not coming. You can easily understand that, okay, these due to these 5 particular devices last bill payload that you have, that we say bill payload, right? So with that particular bill payload, you can easily identify that out of 1,000 devices, 5 devices have stopped sending the data. So this plays very vital role in debugging. So what could be the scenarios in which actually brokers send LWT message to the subscribers? So once it broker detects an IO error or network failure from the publisher, client fails to communicate within the defined keep alive period. For example, keep alive by default is 60 seconds. In that case, if it is fails to communicate, that again you are going to receive the last bill payload. Then client does not send a disconnect packet. Generally in graceful disconnect, it send a disconnect packet, right? These things I am going to show you practically, so you will get very much familiar with this MQTT protocol, right? And either broker closes the network connection because of a protocol error. So in these cases, you are going to get the bill payload that you have set up in your programs or within your Linux utility. So it is very helpful in debugging whenever you are not sure about which device stops sending the data. So you can use this feature. And there is one important concept called retain message. So this concept is very important whenever, for example, any device that went offline, right? That is subscriber device, and publisher is sending the data at 2 minutes, 2 minutes, 2 minutes, right? So by default, retain message means last known good value. So suppose if there are 5 values that has been transmitted, right, at 2 minutes, and device went offline initially, right? Once it connected, it went offline at the first instance only. So it is going to receive the latest value that was published on that broker. It means suppose 1, 2, 3, 4, 5. These values were published by the publisher. So it is not going to receive the all values 1, 2, 3, 4, 5. Whatever the last known good value, it will be received by the subscriber if it is message is retained at that particular topic by the publisher, right? So this is very important feature. For example, any device that is sending the data at 5-minute interval, so whatever data was sent at the first minute, right? And any device that went offline in that case and it got corrected in between, so it will find that whatever the last known good value was available, that topic is received to that particular subscriber. And there is something called clean session and persistent session. So generally, clean session flag, there is one particular thing in MQTT. So whenever you actually clean session flag is true, right? It means you are not requesting persistent session. Persistent session basically take care all the messages are logged until and unless it is not delivered to the subscriber, right? So clean session must be false in that case if you want to establish persistent session between client and broker. So this is very important feature, but this is only applicable in quality of service 1 and 2. Reason is that quality of service 0 does not guarantee acknowledgement, right? So for example, that your publisher is sending the data and your subscriber got disconnected, right? But it has requested persistent session. So whenever your subscriber will come online, it is going to receive all the data that was published on that particular topic. So this is very good feature also available in MQTT, where even if your subscriber device is going offline, you can receive all the data once you get back to online, right? So there is one of the famous question that I've observed from the audiences in many conferences and in many training sessions, that people often ask how long the broker store the session. So answer is, very generic, that until and unless your operating system or a platform where you have installed your broker is totally erasing the data, or your whole operating system got crashes, it will maintain the data. What happens if a client does not come back online for a long time? Usually depends on the memory limit. If the memory is available, your whole data will be preserved there. So there is one more concept called keep alive time. So this is basically used to avoid half open connections, right? So it means whatever keep alive interval you set. So there could be a case where actually your sensor is sending data at 1 minute interval, right? But between 1 minute there is no data. But how my client and broker will be know that they are connected within between in that 1 minute, right? So basically keep alive is a maximum time interval that is permitted to elapse between the point at which the client finishes transmitting one control packet and the point it starts sending the next. It means at 1 second it sends some data, and then next one data will be going to be 61 second, right? It means 60 second is the keep alive interval. In that case, if it is not sending the data, it is okay. So if actual data will not come, basically client send ping request packet and broker send ping response to communicate that yes, connection is still maintains, right? So what are the security options that are available in MQTT? You have username and password based authentication that you can apply at broker side. So the clients that will be having username and password, they will be only able to connect with the broker. Either you can have TLS based communication where certificates, PKI based PKI based features you can implement, public key infrastructure, right? So those people who will be having certificate, they can only connect to the broker. And some of the very famous broker that are available, Mosquito is open source, HiveMQ is also open source, and Mosca is also open source, and broker as a module you can use also Mosca, that is Node.js implementation. So in the next session, we are going to see whatever features we have talked about, how you can implement it practically. So first we will going to use the Linux environment, in which we are going to tell you all the things more in detail, whatever is available in OASIS documentation, like publish packet, how you will realize, pub ACK, pub REC, pub REL, pub connect, con ACK, ping request, ping response. All these things I am going to show you practically. Okay. So like and subscribe to my YouTube channel so that you should not miss any upcoming videos. And I will be keep posting more technical videos related to your IoT. So don't forget to like and subscribe my channel.